The process for removal of protruding fibers from the fabric surface is option A desizing, option B scouring, option C souring, option D singeing. So these four options are basically textile chemical processing basic parts. What are the basic functions during singeing? Desizing. In desizing, the size is removed so that the fabric can go itself and can be easily processed during dyeing and bleaching processes thereon and thereafter. In this process, fats and waxes are removed. Souring. So in souring, the leftover caustic soda is removed, and so on and so forth. Whereas in the singeing process, what singeing process actually is, singeing process refers to the burning of for removal of protruding fibers from the surface of the fabric. It helps to produce an even fabric. So in singeing, the protruding fibers are removed. Protruding fibers removed. How it is removed? Generally, nowadays it is done by gas singeing process. It is a very effective kind of process that is nowadays used in industries. So the process of removal of protruding fibers is known as singeing, whereas the process of removal of size is known as desizing. Removal of size is applied during the fabric manufacturing process, that is sizing process. So in this after the manufacture of the size, during the processing part, the size that is applied is now removed for further chemical processes, dyeing and printing and finishing. So I think it is very clear. These are all basic concepts. These are straightforward questions. There is, if you have read the basics of textiles, then you can easily answer these questions. These are high scoring questions. So you should focus on basic concepts as well. So now coming to the next question. It is also a 1 mark question that says dimethylol dihydroxyethylene urea DMDHU is a crease resist agent, flame retardant, softener. Option D soil repellent. So if you have read what is a DMDHU, so DMDHU is generally used in is a chemical that is generally used in durable press finish, and it helps in cross linking and so on and so forth kind of thing during the durable press finish, and it is used as a crease resist agent that helps in the removal and minimization of creases by the formation of cross links, and it is used in wrinkle and crease resist agent also. So option A is the correct answer. So DMDHU is used as a crease resisting agent, whereas in flame retardant agents, phosphorus substances are used, and softeners and soil repellents. Soil repellencies generally occurs in synthetic fibers, that is polyester. And softeners, these are basically chemical softeners, natural softeners. They are different kinds of softeners that are used. So basically DMDHU is used in wrinkle recovery and crease resist agent. So option A is the correct answer. Now coming to the next question. So this question says, it is from textile chemical processing part. It is also a 1 mark NET question. It says that the wet expression for a padding mangle is set at 80% if the add-on of a flame retardant chemical on the fabric is 2%, then the concentration in gram per liter of a chemical in the pad bath is. So what you have to find, the what is the concentration of this, what is the concentration, TION, concentration of the chemical in the pad bath. So what is given as, assume that the fabric weight is 100 kg. You have to assume this. Assume that the fabric weight is 100 kg, then the add-on is 2%. So add-on, what will be the add-on weight? Add-on is equal to 2%, means 2 upon 100 into 100 means 2 kg. Means 2 kg. And wet expression is said to be 80%. So 80% of wet expression is 80% on the weight of fabric. So 80%, 80 upon 100 into 100, it comes out to be 80 liters, since the specific gravity must be 1 for this case. So what is the concentration in gram per liter? So the if you have to find then the concentration in gram per liter means fabric weight gram, so you have to write it in gram. 2 kg in grams is 2000 grams, 2000 grams upon 80 liters, so the concentration will come out to be 2000 upon 80. 200 upon 8 will come out to be 25 gram per liter. So 25 is the right answer. Then the concentration in gram per liter it is comes out to be 25. This is the right answer. It must be clear to you. So this is from textile processing. So from every part, that is textile testing, yarn manufacturing, fabric manufacturing, basic textile fibers, and thereafter textile chemical processing, all that is asked. You have seen in the recent past year papers that they are focusing on the basic concepts, not in very depth. You just need to know what is the basic, and they don't ask in generally in 1 mark question, they ask straightforward questions. So I think you should focus on this part also. Now coming to the next question. This is from also from processing, chemical processing. It says that assuming Beer-Lambert's law is applicable for dilute solutions, if the molar concentration of the dye in the solution is doubled, then the percentage increase in the absorbance would be absorbance reflectance. You should know what is this. So it is actually occurs in the dye solution, absorbance. So if we assume that Beer-Lambert's law is applicable. So if you have read about the Beer-Lambert's law, so Beer-Lambert's law says Beer-Lambert's law. It says that the molar concentration is doubled. So molar concentration is directly proportional to the absorbance. So if we talk about what is the molar concentration is doubled, it is doubled in the second case. So if it is doubled, then the absorbance would also be doubled in the second case. So percentage increase in absorbance would be percentage increase in absorbance would be absorbance of second minus absorbance of first. Assume it to be x, it is double 2x minus x, and upon the original concentration assume it to be x, final concentration minus initial upon initial original into 100. So it is x upon x into 100%. So since it is directly proportional, if it is doubled, then it would also be doubled. And if we have to write in percentage increase, so percentage increase is 100% increase in the value of the absorbance. So the 100% absorbance is increased if the molar concentration of the dye in the solution is doubled. I think it is clear to you. So these are all 1 mark questions that we have discussed so far right now. Okay. Determine the correctness or otherwise of the following assertion and reason. So in this case also one assertion and one reason is given, and you have to find the answer accordingly. Assertion is said it is from textile chemical processing part. It is a 2 mark question. Application of an optical brightening agent makes white fabrics appear brighter, and the reason is OBA, optical brightening agent, absorb energy in the visible region and radiate back in the UV region. So if you know about what is UBA, OBA, and what is the on which mechanism OBA works, then you can answer this question very easily. So what is OBA used for? OBA is a kind of nail that we use in uh, our homes for cleaning. So on typical principles these works. So OBA is just used to make fabrics appear more bright. So white fabrics appear brighter. So generally this is the right answer, ki the application of OBA makes the white fabrics appear brighter. This is correct. But what mechanism OBA works? It absorbs energy in the visible region and radiate to the UV region. So it says that, so it is the wrong answer. If you know about OBA system, then it absorbs in UV and radiate in visible region, 400 to 700 nanometers. So this is the visible range, and absorbs in the UV range region. So this is oppositely written. In this case, it has said that OBA absorbs energy in the visible region, not in the visible region, but in the UV region, and radiate back in the visible region. So this is wrong. So option A is true, but reason is false. So A is true and reason is false. So the correct option would be option number D. A is true, but R is false. I think you must have understood the concept and the mechanism behind the OBA working. Now, coming to the next question. This says that they determine the correctness or otherwise of the following assertion and reason. Assertion has said that nylon is dyed with acid dyes in acidic medium. Reason is nylon assumes a positive charge in the acidic medium and thus attracts the negatively charged acid dye molecules. So it is also a dyeing question from textile chemical processing. It is also a 2-mark question. So coming to the properties of acid dyes. So if you know about the acid dyes, these are anionic in nature, and these acid dyes are suitable for wool, silk, polyamide. Polyamide means nylon 66 fabrics, and modified acrylic. On what is the pH on which acid dyes are applied? So acid dyes are applied generally from a strongly acidic to a neutral pH bath. Because, and one more thing about acid dyes is, because acid dyes do not have affinity for cellulose. Why? Because cellulose is degraded by the acid. In this case, if we use sulfuric acid or any kind of acid, then cellulose has no affinity for acid, and it get easily dissolved or degraded in the acid bath. And these dyes combine with the fiber by hydrogen bond van der Waals forces through the ionic linkages that is there in the structure. So what is the mechanism? If we talk about these acid dyes, ASO3Na, if we dissociate itself in the presence of water, then it comes out to be ASO3 minus plus Na positive. This is a colored anion. So nylon is dyed in, what the assertion is said in this type, nylon is dyed with acid dyes in acidic medium. It is right. Nylon assumes a positive charge in the acidic medium and thus attracts the negatively charged acid dye molecule. Nylon attracts the negatively charged dye molecules, and nylon assumes a positive charge in the acidic and it attracts the negatively charged dye molecule. So this is also the correct option that is said, and you can easily see from this equation that it is a dye molecule, and nylon, which is positively charged, is get attracted towards the negatively charged dye molecules. So both the assertion and reason are true, and R is the correct reason for assertion. I think it is clear to you. Now coming on to the next question. Determine the correctness or otherwise of the following assertion and reason. The assertion is says that the discharge printing of dyed polyester fabric is not possible, and the discharging agent damage the polyester fiber significantly. You have to answer this if the assertion and reason both are true, or if any one is true or both are false. So if you look at the discharge printing of polyester, so polyester fabric is dyed with dischargeable dispersed dye, and then it is printed with a paste that containing reducing agent for white discharge, and non-dischargeable dyes for color discharge. So what it says, discharge printing for dyed polyester is not possible. So it is possible. It is possible because discharge printing is with the help of the reducing agent, dischargeable dispersed dye with the help of the reducing agent, and non-dischargeable dyes for in case of color discharge. So it is possible. The assertion is wrong. So if you notice, if assertion is wrong, then if you get by trick, if you know reason or not, then you can answer this question, because if assertion is wrong, then we are left with only the single option, that is option number C, because in option A, B and D, A are true. So you can answer this question if without knowing the reason or not. So the option C would be the right answer. But just read the reason for this. Discharging agents damage the polyester fibers significantly. It is the wrong. It is wrong, because discharging agents are used in case of polyester fibers for the dyeing and printing process, and with the because but in this case it is used with the help of the reducing agents. But if the fabric is dyed with HTHP method, then it is difficult to discharge the ground. But if the ground shade is obtained by carrier dyeing method, then it is easy to discharge the ground shade. And how this dyeing and process is done, if you have read, the cloth is first padded with dispersion of dischargeable dye, and then it is dried at low temperature so that the color does not get fixed at this stage. And the bath that contains around 2 gram per liter of sodium alginate that is used as thickener that make the entire paste acidic, along with the use of tartaric acid with a pH of around 5 to 6. And then the fabric is dried at around 60 degrees Celsius, and then it is printed with a paste. In this type, the entire dyeing and thereafter printing process is done. So the reason that is said that the discharging agents damage the polyester fiber significantly, it is completely wrong. Both the assertion and the reason are wrong. So option C is the correct option. And we have answered this question as well. Now coming to another type of questions, that is NAT type of questions, numerical answer type questions. We will see these questions ahead. Now coming on to the next question. A counter-flow heat exchanger is attached to a stanter for waste heat recovery. Consider the following data. Ambient temperature is 30 degrees Celsius. Temperature of the exhaust from a stanter is 150 degrees Celsius. Temperature of the exhaust at the exit of the heat exchanger is 100 degrees Celsius. And specific heat of the exhaust is 0.42 kilocalorie per degree per kg, and specific heat of the air is 0.24 kilocalorie per degree per kg. It is also, you can also see in this figure that ambient air in, and here it enters, and this is the wave from where it is exhausted in from a stanter, and from hot air to stanter. This is a typical figure of a heat exchanger. From here hot air to stanter goes out from this. So it is said that in question that at a steady state, if the mass flow rate of the exhaust gas, the incoming air are the same, assuming heat loss as 0, the temperature in degree Celsius of the air at the exit of the heat exchanger towards the stanter, rounded off to 1 decimal places. This is the question from the general question from waste heat recovery part. So in this question, the simple concept that is applied as heat flow from a stanter is equal to heat flow out of the stanter. That means the heat that is flowing from the stanter, that is exhaust, is equal to the heat that is flowing out of the stanter, that is from the temperature of the air out. Means this total heat from the stanter exhaust is equal to the total heat flow out of the stanter. Now we will solve these questions using the data that is given in this question. So solving this question, it is said that heat flow from stanter exhaust is equal to heat flow out to stanter that is temperature of air. So if you calculate this heat, what is the formula of heat flow? Heat flow is mc delta T. C is specific heat capacity, mc delta T, mc1 T1 T delta T is equal to mc delta T. C1 C2 you can replace as C1 and C2. So since the mass is same for both these, so m to m got cancelled. Since C1, if you write from heat flow from stentor, that is exhaust, that is the specific heat capacity is given out to be 0.42, and delta T is 150 minus change in temperature from stentor to exhaust. If you have seen in the figure, that is written as 150 minus 100, and delta T C2 is given out to be 0.24, and delta T is, you have to find the final temperature. So T is temperature and the ambient temperature, that is given as 30. So 0.42 into 50 is equal to 0.24 times T minus 30. So 87.5 is equal to T minus 30. If you will calculate this, then T will come out to be 117.5 degrees Celsius. And you have to write the temperature in one decimal place. So the correct answer would be 117.5 degrees Celsius. It is the right answer. So the basic concept is heat flow formula is mc delta T, and this was a simple calculative question. I think it must be clear to you by now. You should also focus on these types of questions as well, because they ask sometimes this, and sometimes they can ask from latent heat of fusion also. So just be aware of these types of questions as well for the upcoming GATE examination. Now coming on to the next question. Consider the following isotherms at equilibrium for two dispersed dyes D1 and D2 dyed on polyester. If the partition coefficient of these dyes are K1 and K2 respectively, then the value of K2 is to K1 is, you can see this equation from this figure. K2 is, for D1 it is K1, and for D2 the partition coefficient is K2. So for dispersed dyes D1, for dye D1, we can say that partition coefficient is, the formula for partition coefficient is df dye in fiber upon dye in solution. The formula is df upon ds. It is the general formula for partition coefficient, dye in fiber upon dye in solution. If we talk about d1, then dye in fiber is 5 or dye in solution is 0.1. So we can say that 5 upon 0.1. 5 upon 0.1, it will come out to be 50. And for dye D2, K2 is equal to df upon ds. In this case it is also same, but for D2 the dye in fiber is 10 and dye in solution is 0.05. So dye in fiber is 10 and dye in solution is 0.05. So it will come out to be 200. So K2 is 200, and what we need to find is value of K2 is to K1. So it is very simple. Thus K2 upon K1 is equal to, K2 value is 200 upon 50. You can solve this as 4. It will come out to be 4. The value of K2 is to K1 is 4. The answer is 4. I think it is very much clear to you. This is the entire GATE 2021 textiles part. These questions are not very difficult. Just you need to be clear with the basics. I think you like this types of solutions. So all the best for your examination. Now we'll meet you in the next upcoming sessions. Till then, keep learning. Thank you.